Hi guys, welcome to our channel of Sciences and Mathematics. Today's topic of discussion is going to be on the unity vector. And the concept of unity vector is going to assist us in trying to interpret, of course, our last discussion of on components of vectors, whereby we said that some of the components of the vectors, especially on the cross product, are going to be maybe disappear or maybe form a factor which is 1. So today we are going to illustrate on what kind of product we can achieve when we are trying to find a cross product of some of the components of the vectors that we had discussed about. So for that case, thank you and welcome. So today's topic of discussion is going to be under vectors, and basically it's going to entail the concept of unity vectors or a unity vector. And this is going to assist us interpret on how we are already represented some of the vectors in some of our videos, whereby we said that the product of some of the components of vectors are going to give us a specific value or maybe a specific direction. And some of these laws we're going to see them apply maybe in the concept of electricity, like the hand rules that maybe dictate the position or the position of a magnet or the direction of magnetic fields and other aspects of maybe physics, especially on the topic of electricity. Now we're going to see that this unity vector is going to open for us a way in which we can be able to understand how the interplay between these components work, and this is going to assist us in solving some of the problems that we may encounter in vectors. So in this case, from the definition, a unity vector is a vector that consists of the three components of the x, y, and z direction in our three-dimensional space that we are talking about. For a vector or a position vector r, then we can be able to represent the three components using that. So in this case, we're going to see that for this unity vector, these particular components are going to be formed from the concept of unity. We understand that the concept of a unit implies 1. So therefore, we're going to just have our rectangular coordinate system for x, y, and z direction. And we said specifically we can be able to represent this one using I, j, and k. So for that case, whenever we're talking about unit, it's a displacement of 1 unit in the x direction, 1 unit in the y direction, and 1 unit in the z direction. So that is going to form what we call a unity vector. So therefore, whenever we are trying to represent this one in terms of the three components of x, y, and z, we can say that the position vector maybe for r, let's say this is r, the position vector for r, let's say from this point to B. We can say the position vector of maybe a particle at point B can be represented using this R, which has got the components of 1 in the X, 1 in the Y, and 1 in the Z direction. So therefore, for the X direction, then we're going to represent this one using, so generally for just P, it's going to be X, Y, and Z. But we know that for P, this is going to be 1, 0, 0 in the x direction, and for this is x, p for y direction it's going to be 0, 1, 0. So therefore, respectively in the y direction and in the z direction it's going to be 0, 0, 1. So therefore, if we will try to look at these three different aspects, therefore we can represent the general vector by using x, 0, 0. So the second one is going to be 0, y, 0. And then the last one is going to be 0, 0, z. So that is a general representation for this particular case of a unity vector. Now suppose we have seen from the concept of matrix how we can be able to find a magnitude or maybe a determinant of a particular matrix, or that specifically refers to the cross product. Now suppose we have a, hope we have seen this. Now suppose we have a vector that can be represented using the two components, maybe for I, we just write this one somewhere. So for our case, x, so x, 0, 0, so 0, y, 0, this, and then for z, 0, 0, z. So this is a general representation, and then we have said for our unity vector, then it's going to be 1, 0, and then this is for x. For y, it's going to be, this is a 0, 1, 0, and then for z, it's going to be 0, 0, 1. So suppose I have a cross between I and j, then I'm going to do this using this particular case, whereby I have I, which is 1, 0, 0, and then 0, 1, 0, for this and this one respectively. So in order for me to find the cross product for that, I will just do using the normal way of finding a determinant, which is this is I, j, k direction. So there's no component of j. So in this case, I'm going to find it using, first by ignoring the first column. Therefore, it's going to be, this is 1 minus 0. And then this is 1 minus 0. And then I'm going to have, ignoring the second column, 0 minus 0. The third column is going to be, oh, no, I have to just do a confirmation for that. So that is correct. So we just have to do finding a determinant of that, or trying to solve for this. That's the cross for I and j. So therefore, we ignore the first component, the I component for this, and then we'll find that the first, that is for the x, is going to be represented by 0, the product of 0 minus 0. So then we ignore the second column for that, then we find the product for this 1, 0. So it's still 0 minus 0, and this is for the x, y, and for the z, we're going to ignore this last one, and then we find this a product of 1 minus 0. So this is going to give us 0 for the x, 0 for y, and 1 for the, so the result of the product for that particular case is going to give us this. And this basically, as we said, is going to represent, this is the I j, okay, so this is going to represent the k component of that particular vector. So therefore, a cross between I and j is going to give us k. So it's false in that respective order, that for I cross j is going to give us k, and then we are going to have, so I cross j is going to give us k, and still if we follow the same format, j cross k is going to give us I, and then k cross I is going to give us j. So in this specific order, we're going to see that the cross product is going to display a unique particular way. But when we're going to look at this particular concept in contrast with the dot product, where we had I is equals k is equals j, which is the same as 1. So this one is going to give us products of this respective vectors that we, or the vector components that we have talked about. Now we're going to look at the example of one of the cross product of the vectors that we have talked about, and try to see what are some of the products that we're going to find. So I hope that this concept of a unit vector from the illustration that we have given has been able to assist us in trying to illustrate the respective components for the x, y, and z direction. And specifically for our unit vector, we have said that this x, y, and z are represented by 1. And then therefore we have said that there's a characteristic in way this cross product of the two components is going to give us a specific component, in that for I and j is going to give us k, jk is going to give us I, and ki is going to give us j. So this is going to be applicable in some of the mathematics or physics questions that we may encounter, that is going to require us to display the components of vectors. And there's one of the aspects that I've forgotten. Maybe we can be able to represent this ij and k components maybe using this symbol, in that when I'm representing the k components, I just use that small hat for the representation. So I'm just going to do away with this so that we can be able to look at the sample question before we close on this concept of unit vectors. So basically it's not going to deal with unit vectors because we have already illustrated using the concept of a determinant that we have done. But this is going to pertain maybe to just a general explanation, but basically which still lies under the concept of this three representation of three vectors in three-dimensional space. So suppose I have a vector u, which is 1, 2, -2, and then I have another vector v, which is represented by 3, 0, and then 1. So therefore, suppose I'm asked to find a cross product for that specific vectors, I'm going to arrange these specific components in the I, j, and k direction, and then I'm going to find the magnitude using this specific order. So this is 2, 0, -2, 1. I hope I've done the representations the correct way. So therefore, this is going to use the normal way of finding the determinant that we have talked about, in that first you take the I component of that particular vector, and by finding the magnitude for that I component, we just ignore this column and then it will be 2, 0. So for ignoring this, we are just only going to have this component, -2, 1, and then minus j. So this minus sign is, we are going to see on how we are going to represent this using a formula by expanding that formula, but for this case, this is going to be the negative value irrespective of the components which are going to be illustrated on that. So if we ignore this column, then this is going to be the magnitude for 1, 3, -2, 1. And then we are going to have the last component we add. So we ignore this, it's going to be 1, 2, so k for 1, 2, 3, 0. So in trying to find this for this one, we just have a cross, the difference of the cross multiplication of the two, whereby it is 2 times 1 minus 0. So the first one is going to give us 2i minus, so this is 1, so it's going to be 1 minus 6, which is going to give us 7. So for the j component, the determinant for this specific case is going to be +7, but there's a minus sign here. So this sign is going to cater for the j component. And then lastly, we are going to have plus, this is 1 minus 6. So therefore, this one is, no, basically this is a 0 here. So we are going to have 0 minus 6. So it's going to be k minus 6. So therefore it's going to be 2i minus 7j minus 6k. So that is going to be the resulting, of course, vector for that particular representation. And in this case, therefore, we can be able to illustrate that whatever product we're going to get is 2, 7, and then minus 6. So this will be the answer for this. Specifically is the answer for this. This is how we're going to obtain that one. Now this one and others are going to be worked out using the same example or specific strategy, this specific strategy. But we're also going to use the expanded formula in order to find the answers to this kind of questions, in case we come across them. But of essence for our discussion for today is for us to identify the concept of a unit vector and try to see that the product of these various components of the unit vectors that we talked about, I, j, and k, are going to give us specific components, maybe like the I and k and j that we talked about, giving us k, etc. So I hope that is going to assist us in working out some of the areas in vectors, and we shall maybe be adding other additional concepts as we come by them. So that is it for today, guys. Bye, God bless.